Hi there, it's Mrs. Tremblay yet again, and today we're going to solve one-step multiplication and division equations. So we're in section 2.5 in your book if you're following along. Previously, we just learned how to solve one-step addition and subtraction equations, and we use the blocks to help us. We're going to kind of use some logical reasoning to help us through this. So one-step multiplication, division, and equations. Basically in these, the variables either being multiplied or divided by something, and we have to do one thing to undo it. That's why they're called one steps. The goal is still the same. The goal of any equation is to find the value of the variable that makes it true. So if I put an equal sign between the two, there's a value for the variable that makes it true. In order to find the value of the variable, we learned that we need to get it by itself on one side, or isolate it. Again, I know that you have learned how to guess and check these, but guessing and checking in math only goes so far. Problems are going to continue to build on one another, and they're going to get more and more complicated, and it's really good to have kind of like a systematic way to do it rather than just guessing, because I know you don't want to take longer than you have to solve problems, right? So I would like you to think about these things, and pretty sure we should have done this in class together, so this section right here is kind of if you weren't in class or maybe it went too fast, kind of rewatching it. But anyhow, look at this problem here. I have a 3 next to the x equals negative 12, and we learned that when you have a number next to a letter, it means multiplication, right? So I know that a lot of you probably already know what this answer is by guessing and checking, but I want you to come up with what can you do to this side to get the x by itself, and whatever you do to this side you'll have to do to this side. And I'll kind of brainstorm some things I think that you would say, and then we'll kind of cross them out after. So if you have 3x equals negative 12, you just learned addition equations, right? I'm guessing that a lot of you would say, well, I'm going to add a negative 3 to each side. Now, question for you. If I gave you the expression 3x plus negative 3, because that's what this is, would that give you just plain old x? It wouldn't. Those aren't even like terms, right? We can't do that. Now, others of you might be thinking, okay, well that didn't work. What if I just add a negative 2x? If I do plus negative 2x, 3x plus negative 2x, that gives me 1x, right? Which is the same as x, so we just got x by itself. But whatever you do to one side, you have to do to the other, right? So if I'm going to add a negative 2x to this side, when you take 12x plus negative 2x, those aren't like terms. So what you just did was you changed the equation so that now we have 2 x's in there instead of just 1x by itself. So using addition, using that opposites that we used for our addition equations, isn't what's going to do it here. I'm going to rewrite this problem over here. And think about this. In order to get x by itself, isn't any number divided by itself 1? Right? And I know that we can't add terms that aren't like terms. But we're allowed to multiply and divide, right? So if you take 3x and you divide it by 3, 3x divided by 3 gives you 1x, right? So 3 divided by 3 is 1. It gives you 1x. And isn't 1x the same thing as x? Yes. So whatever you do to this side, we have to do to this side too, correct? What's negative 12 divided by 3? It's negative 4. So in that equation, 3x equals negative 12. If I divide both sides by the coefficient of x, we end up getting one of the variable, which means the variable is by itself. That's all you have to do. So if you see a multiplication equation, all you have to do to solve it is divide by the coefficient. Now here's another one, because we're focusing on multiplication and division today. I have x divided by 3 equals negative 6. Now I'm guessing that from this one you're understanding that adding a negative 3 to each side isn't going to do it. We want to figure out how to be left with just this x. We talked a whole lot about cross-canceling at the beginning of Unit 2, right? And I know that when I multiply fractions, if I have the same number across from each other, they would cancel out. And if you can cancel out that 3, doesn't that mean x will be by itself? So that would mean I'd need a 3 up here, right? And multiplying by 3, that's the same as multiplying by 3 over 1, isn't it? Just so you can get the whole picture here. So if we multiply each side by the number x is being divided by, watch what happens. Those will cancel. You'll be left with x divided by 1. What's x divided by 1? Yeah, it's x. Any number divided by 1 is itself. Now we multiplied this side by 3. I just put that 1 underneath it to show you the whole cross canceling. I'm going to multiply this side by 3. Negative 6 times 3, that's negative 18. If you take negative 18 divided by 3, won't you get negative 6? Yup. So the moral of this story, when you're solving one-step multiplication and division equations, our little steps, these are properties that allow us to do this. The division property of equality says that I can divide each side of the equation by the same number and make an equivalent equation. So if you're trying to solve a multiplication equation, all you need to do is divide each side by whatever the variable is being multiplied by. On the flip side of that, the multiplication property of equality states that multiplying each side by the same number produces an equivalent equation. So to solve a division equation, you just need to multiply each side by whatever the variable is being divided by. Notice we didn't change any signs, did we? There was no sign changing going on at all because that's not how we isolate the variable with multiplication and division equations. We basically just use opposite operations. So let's try a few of these here. All right. So in our first equation, we have 4x equals negative 18. I'm going to draw the line. It's still a balanced scale, right? I see that x is being multiplied by 4. So to get x by itself, I'm going to divide each side by whatever x is being multiplied by. Because 4 divided by 4 is 1, and 1x is x. If I would have changed the sign and divided by negative 4, wouldn't I now have a negative x? Nobody wants a negative x, trust me. So you divide that side by 4, that means we also need to divide that side by 4. And yeah, sometimes you won't get lovely whole numbers, sometimes you'll get decimals and it's okay. A negative 18 divided by 4 gives you negative 4.5. That's all we're doing. And I'm guessing if you guessed and checked, arriving at negative 4.5, a decimal number, may have taken you a long time. By the way, we checked these the same way. Here's my original equation. It's 4x equals negative 18. If we're saying x is negative 4.5, then 4 times negative 4.5 should give you negative 18. And you can just check that one in your calculator. When you take 4 times negative 4.5, you do get negative 18. So it just takes a minute to check these. It's not even a minute. That took us like 2 seconds. It's so worth it. All right, take a look at the next one. This is also a multiplication equation because my letter's over here this time. That's okay. But n is being multiplied by 25 hundredths. I'm going to divide each side then by 25 hundredths. We divide by the coefficient of the letter. This negative 20 doesn't have a letter after it. Don't divide each side by negative 20. Divide by the number in front of the letter. Because when you divide this number by itself, you get 1, and 1n is the same as n. That means on this side, I also need to divide by 25 hundredths. So when you take negative 20 and you divide it by 25 hundredths, you get negative 80. So negative 80 equals n. That means the same thing as n equals negative 80, so don't worry about it. It's okay that the n's on the other side. If you're like, I don't believe that, how come that number's so big? Is that really true? Then see if negative 20 is equal to 25 hundredths times negative 80. When you take 0.25 and you multiply it by negative 80, you do get negative 20. So it's right. Again, it just took a second. All right, this last multiplication equation looks kind of tricky. It's really not, because you remember that when a variable doesn't have a number in front of it, there's really a 1. You might be thinking, well, wait, this is already set because the variable's already by itself. It's not. This is negative p. It's not p. So we need that negative sign to go away. And I think rewriting this with the coefficient will help. This is really negative 1p equals negative 24. And how do you get rid of a number that's being multiplied by the variable? We're going to divide by it. So I need to divide by a -1. Need the digit to stay exactly the same, because a -1 divided by a -1 is a +1. And +1p is the same as p. Now I need to divide this side by -1 as well. Whatever you do to one side, do the same exact thing to the other. And -24 divided by -1 is a +24. And you're done. And up here it says the opposite of p is -24. Is the opposite of 24 -24? Yes, it is. So we know that it's right. Okay, let's try some division ones. Turn your page. Okay, in these equations up here, the variable is being divided by something. I'm going to draw my line separating the sides, and you already learned that to undo division, all we need to do is multiply by whatever the variable is being divided by. So n is being divided by 3. To get n by itself, I'm just going to multiply by 3. That allows me to cross cancel the 3's, because when I multiply by 3, that means that 3 is technically in the numerator spot, right? That's what allows me to cancel it out. And n is left being divided by 1, and n divided by 1 is n. If you multiply this side by 3, you need to multiply that side by 3. I didn't change any signs. You need to leave the signs alone. -7 times 3 is -21. That's it. To check it, my original equation is n over 3 equals -7. Does -21 divided by 3 give you -7? It sure does. So all we did was replace that n with what we got for n and made sure that it was true at the end. That's it. All right, this time the variable's on the opposite side. It's okay. You're not multiplying each side by -12. I want to multiply each side by whatever the variable is being divided by. Y is being divided by 5. To undo that, to get y by itself, I'm going to do multiplying by 5. So y over 5 times 5, those cross cancel and y is by itself. Now I need to multiply this side by 5. And a -12 times 5 gives us -60. So -60 equals y. Again, it's okay that that y is on the other side. It's no big deal. You're not sure, is this right? I want to know, does -12 equal -60 divided by 5? I just replaced that y with the -60. And if you check it out, yep, -60 divided by 5 is -12, so we know that it's right. All right, this last division equation looks a little bit different here. I'm going to draw my line. Remember, I need x by itself, right? There's this little negative sign right here. Do you see it? I sure do. And I have the 3. That means I need this negative and the 3 to go away so that x is by itself. With this type of problem, when I see a negative right in the middle like that, I would just put it with the denominator, because we learned before that it could go with the top or with the bottom, right? I don't want to put it with the top, because then I have -x. And then I have an extra step. I want x by itself. So if you see a division equation like this, there's a negative sign in the middle, I would drop it down, put it with the bottom. And now what am I going to multiply each side by? A -3. That allows you to get rid of the negative and the 3 so that you can get x by itself, which is your goal. You want to isolate the x. If you multiply this side by -3 to get x alone, you need to also multiply that side by -3 so that it stays balanced. A -15 multiplied by a -3, negative times a negative is a positive, and it will be a +45. If you're not sure if this is right, go back to your original equation. It was the opposite of x over 3 equals -15. 45 divided by 3 is 15, and this is saying it's negative. And -15 equals -15, so you know that you're right. I wish I could say that we're completely finished, but we're not. We have some more kind of crazy looking equations to deal with, but I don't want them to feel crazy to you. I want them to be really super easy. So let's keep going. If you need to pause, take a break, shake it off, go ahead. Welcome back. Okay, these equations are in the same kind of family that we've been solving, and we are going to use a method called using a reciprocal. And you kind of already know what a reciprocal is, basically, right? You have a fraction, you flip it around, that's a reciprocal. The multiplicative inverse property, and you know I want to say multiplica, because I always do. The multiplicative inverse property states that when you multiply reciprocals, you're always going to get 1, right? So if I'm trying to get a result of 1, I can multiply 3/4 by its reciprocal. The reciprocal of 3/4 is 4/3, right? When you do that, you end up getting 12 over 12. And isn't any number divided by itself 1? Yes. And looking at this next one, if I'm trying to get 1, I know the reciprocal of 5/6 is 6/5, right? If I'm trying to get a positive 1 and you're multiplying, if this first number is negative, this also needs to be negative, right? So just flip the digits, but keep your signs. And this last one, -7 times what would give me a positive 1? Well, remember, this -7 really means that. So if we flip that, I can put the 1 over the -7. You would end up getting a -7 over a -7. And isn't -7 divided by -7 1? Yes. So here's proof that when you multiply by reciprocals, you're always going to get 1, right? And wasn't that our objective in all of these kinds of equations? I wanted to get 1n. And when we had our multiplication equations, I was trying to get 1x. So if you see an equation that has a coefficient of the variable that's a fraction, all you have to do to get the variable by itself is multiply each side by the reciprocal. Because it's your job to get 1h, right? Or just h. So I know that if I take 3/8 and multiply it by 8/3, that's 1, right? Because you can look at it as canceling out. Those would cross cancel, and h is alone. There, you got that side done. But now, whatever you do to one side, you have to do to the other, right? So that means I want to multiply this side by 8/3 as well. So whatever you do to one side, do to the other. With these, I would definitely cross cancel. I mean, you could bust out your calculator and solve it too, but basically if I give you a fractional problem, I want you to give me a fractional answer. So in looking at this, I would go ahead and say, okay, well, 3 and 9, those are both divisible by 3. And you end up with -3 times 8, which is -24. And then 1 times 1 is 1. And you wouldn't really do that, right? We're just going to say h equals -24. And bam, you are finished. So these are a little bit different than the others because it's not just, I mean, you could look at this as a division equation or as a multiplication equation, I guess. But when you see fractional coefficients, all you have to do to get rid of it is multiply it by its reciprocal. So here I have 2/3 x, right? I want that 2/3 to go away. That means I need to multiply this side, because that's the one with the x on it, by 3/2. When you take 2/3 x times 3/2, the 3's are gone, the 2's are gone, you're left with plain old x. Whatever you do to one side, you have to do to the other. So that means I need to take this -14 and multiply it by 3/2. Again, I would use cross-canceling here. I see that 2 is divisible by 2, and a -14 is divisible by 2. You're left with 3 times -7, which is -21, over 1 times 1, which is 1. I'm not going to write -21 over 1. I'm just going to write -21. That's it. And to check it, you would do the same thing. You can take 2 divided by 3 and multiply it by -21, and you'll get your solutions. All right, the last one of this type, I'm going to draw my line. I have -4/5 x times -8. Now remember here when we had -5/6, we didn't change the sign, right? We kept that sign and flipped the digits. So same thing here. In order to get x by itself, I need to multiply by -5/4. Because a negative times a negative is a positive, and that's how I'm left with a positive 1x. Those would cancel. And then if I do that to this side, I need to do it to this side as well. So -8 times -5/4. Again, I'm going to cross cancel. It's the way to go. Saves so much time. I see that 4 goes into 4 once. 4 goes into -8, -2 times. I'm left with a -2 multiplied by a -5, which gives me a positive 10. All right, we have one last little part. Hopefully it will just take a few moments. I need you to be able to write equations too. It's kind of important to be able to understand the words. Okay, so writing and solving one-step multiplication and division equations. Keywords for multiplication are product of, multiplied by. So if I say find the product, that means find the result of the multiplication problem. The key division words are quotient of or divided by. So if I say, what is the quotient of, that means what's the result of this division problem? So our step one, we're going to write our 4 equations in these examples, and then we'll go back and quickly solve them. All right, so step one, write the equation. Let's do it. It says a number y multiplied by negative 2.2 is 11. Whenever you see that word is, it means equals. So y multiplied by negative 2.2 is 11. Now, I'll know a lot of you want to do this. When you see multiplication equations, you don't normally see them written like that, do you? When you multiply numbers in letters, don't you always see the coefficient first? So even though it says y multiplied by negative 2.2, I would still like you to write it like this. Negative 2.2y equals 11. That means the same thing as this, but in algebra, the number always gets to go first, and we express multiplication between numbers and letters like that. Why, you say? Well, can't that x be mistaken for a regular x? It just gets too confusing. So that's, I'm guessing, why they dropped the sign when you're multiplying a number and a letter. Anyway, that's that. Next one says the product of, so I know that means multiplication, the product of what? Of 12 and a number p. So I want the product of that, and it says it is 60. So the product of negative 12 and p means multiply those two. Again, I dropped the sign. I would write that as negative 12p, and it says that is 60. All right, moving along. A number n divided by 8. So divided by means we're going to divide. And what are we going to divide? N is going to be divided by 8, and that is negative 7. So to show n divided by 8, yes, you could write that. Usually when you see these equations, though, it'll be written as a fraction. Either one's correct. You can't put the 8 first, though. N is what's being divided by the 8. So be careful with that. All right, last one here where you have to write the equation. It says the quotient of. That means division. So I want the quotient of m and 5, and that is negative 9. So to express the quotient of m and 5, I can say m over 5, or m divided by 5. M needs to go first because with division, order matters. And that is negative 9. All right, last thing I want us to do is just go back and quickly solve these. Maybe you want to hit pause and go back and solve them, and then hit play and see if you got them right. Welcome back. All right, the first one, this is a multiplication equation. To undo it, all we need to do is divide by the number in front of the y. Divide by the coefficient. Don't change any signs. So I would divide each side by negative 2.2. Negative 2.2 divided by negative 2.2 gives me 1y, which is y. And when you take 11 and divide it by a negative 2.2, you get negative 5. And that one's done. All right, next, again, this is a multiplication equation. To undo multiplication, we're just going to divide each side by the coefficient of the variable. Negative 12 divided by negative 12, gone, that's 1. We're left with p. And when you take 60 and you divide it by negative 12, yep, you get negative 5. I didn't even do that on purpose. They're both negative 5. It's crazy. All right, next, this is a division equation. N's being divided by 8. To cancel that 8 out so that n's by itself, I need to multiply each side by whatever the variable is being divided by. So those 8's would cross cancel, n's left alone. I need to also multiply that side by 8, because whatever you do to one side, you must do to the other. And negative 7 times 8 is negative 56. And last but not least, again, another division equation. I'm going to multiply each side by 5. That allows me to cancel them out. And m divided by 1 is m. Negative 9 times 5 is negative 45. And finally, you are done. Go give yourself a pat on the back. See you tomorrow.